saw some other notes in the margins or something. So you'll get one of my copies on your formula sheet for every test and quiz. But let's take a look at this problem. A set of data has a mean of 75 and a standard deviation of 8. If the data is bell-shaped, what percent of the data falls between 67 and 83? So what rule are we going to use if it's bell-shaped? The empirical rule. Get out your formula sheet so you can kind of look at this and know where to find things. So the empirical rule tells you it only works on symmetric data. Based on that, we can know how much should fall within each standard deviation of the mean. So the key, we have to know how many standard deviations from the mean we're looking at. So the mean is 75. So one standard deviation, you would subtract 8 and add 8. So that would take me to 67 and 83. So this is one standard deviation. So what percent? 68%. Okay, second thing. What I said, if the data is not symmetric. So if it's not symmetric, what do we have to use? Chebyshev's theorems. It's empirical. This one we use Chebyshev's. Okay, but again, we need to know how many standard deviations. So we want to go between 51 and 83. So let's keep subtracting 8 would take me to 59. If I subtract 8, that's 51. Add 8. So this is 2 standard deviations. So 51 to 99 is 3 standard deviations. So Chebyshev says we do 1 minus 1 over k squared. K is the number of standard deviations. So 1 minus 1 over 3 squared. It's 0.8 repeating. So that would be 88.89%. Is that okay? Alright. Next problem. I just want to kind of sort this. I'm giving you 4 words. And we need to figure out where they would best go in here. So measures of center. We use those to find the center of a set of data. What were the measures of center that we talked about? Mean, median, mode was one of them. We just don't use it a whole lot. Measures of dispersion told us how spread out the data was. So that was like the range, standard deviation, interquartile range. Okay, so measures of center. In this case, we're looking at mean and median. Which one is better if your data is symmetric? The mean. It gives us more information. But we've talked about if our data is skewed, if I enter test scores and I give somebody a 0, what does that do to my whole class average? It drops it a lot, and then the mean doesn't really show me the center anymore. So if the data is skewed, we would want to use the mean. Okay, so measures of dispersion. Which one usually gives us the best information? So it's our go-to if we have good data. Standard deviation. So if it's symmetric, we want standard deviation. But, just like the mean, if I have one point that's way off, it throws the standard deviation way off. So if our data is skewed, we would go to interquartile range. Okay, so just knowing the best thing to pick based on if we have symmetric data or not. Is that okay? Alright, look at this one. A model railroad kit includes straight tracks in 3 different lengths. 60% of the straight tracks are 12 inches long, 30% are 8 inches long, and 10% are 6 inches long. What is the average length of a straight track? So what would we do there?
We could do like 12 times 6, 8 times 3, 6 times 4.
We're finding an average. This is a weighted average problem. So remember, we took each value times its weight. So my value, we have the 12 inches long, and the weight, what percent was that? 60 was. Okay. The next value, we had 8-inch long ones, and those had a weight of 30. We had 6-inch long ones, and those have a weight of 10. And then we divide by the sum of the weights. So 60 plus 30 plus 10, 100. You could have also, if you've done 0.6, 0.3, and 0.1, you would just be dividing by 1 here. So whether you convert it to percents or not. So we get an average length of 10.2 inches. Is that okay?
Yeah.
Alright. I think I have one more. This is the final example. The mean weight of a 20 to 29-year-old female is 156.5 pounds with a standard deviation of 51.2 pounds. The mean weight for males in the same age group is 183.4 pounds with standard deviation of 40 pounds. Who is relatively heavier, a female weighing 160 or a male weighing 185? What do we have to do? Sort. So we need to kind of sort our information. So we have the female. We had the mean for the female was 156.5. Standard deviation 51.2. Male mean was 183.4. Standard deviation of 40. So the particular value for the female we're looking at is 160. For the male is 185. So remember z-score formula, just like all of these, it's on your formula sheet. X minus x bar over x. Your value minus the standard deviation. Sorry, your value minus the mean divided by the standard deviation. Z-scores, and then we have to answer the question. We want to know who was relatively heavier. They're both higher than the mean, so we want the one that is the most high, so that would be who in this scenario? Any questions? So we're going to spread out and take this quiz. You just need a pencil and a calculator. I'll give you a formula sheet.